Hello, I am Juan Arrieta from the NASA Jet Propulsion Laboratory in Pasadena, California. It is called the Regolith Biters, a divide and conquer architecture for sample return missions. So it's a long name, but it's actually a very simple concept. Regolith is just a name that we give to the dust, which is on the surface of any natural body in space. So, and all the little rocks, the little dust, even the bigger boulders, that's what we call regolith. The attempts that have been made so far to sample, bring a sample from those bodies to Earth, have been kind of monolithic approaches where you send a big spacecraft that has a big sampling device attached to the spacecraft, and it attempts to touch the body and go. So that's called the tag approach, touch and go. And that is all good on paper. The problem is these bodies are so small and sometimes they rotate so fast that it's very difficult to approach them. So what I did is, okay, what happens if we just do not couple the sampling device to the spacecraft? So let's just release a series of little things, of little agents, little robots that are gonna impact the surface of the small body and bite it. Bite it, as in taking a big bite, keep it in their mouth, and then eject back to orbit so that we can trap them. So it's a long answer to say they are called the Regolith Biters because literally that's the only purpose that they have. And right now the only thing we have in our mind is, imagine Pac-Man. That's what we have. Somehow it got embedded into our mind, something that is with its mouth open. As soon as it touches the regolith, it closes the mouth, so it's a sphere, and then it bounces off. Physics and the propulsion technologies that we have today or in the foreseeable future are sufficient to, number one, approach the asteroid, which that is almost a solved problem. We know how to approach asteroids and comets. Number two, being able to remain within a safe distance from the small body. And third, rendezvous with these guys. That is really the challenge. The challenge is actually to trap them because they have no propulsion. Probably they would not even have telemetry. So you have to track them, passively speaking, meaning they would not be emitting any signal. You have to see them somehow. And then say you have chances of collecting 10 out of the, say, 50. Number one, it is physically credible, what we're saying. It is incredibly challenging, but it is definitely within the realm of possibility. And every one element is physically possible. What has never been done before is to actually chain them together. I think a NIAC is the first opportunity to say, all those little scattered elements are here. I have published the research, it has been read by other experts, has been agreed upon, and the fundamental principles hold together. It is the first shot at a full management experience that I have. So I think NIAC is not only developing technology, it's also developing managers of technology. And I'm one of 18. If 10% are successful, that's already a lot, because investing in the unknown is really what NASA should be about.